So now we're going to get into exact values, okay? And this is probably one of the more important topics in trig that we really need to get a handle of, figuring out exact values of certain angles. So we can remember back from chapter 1a, when we did that intro to trig lesson. Remember from chapter 1a, that the cosine and sine of an angle can be defined by x or y. In our unit circle. So the unit circle is a circle of radius 1 that is centered at the origin. And so we can find the sine of the angle and the cosine of the angle, whether we have the value of x and y. So let me draw a bit of a diagram just so we remind ourselves. We have a vertical axis and a horizontal axis. And then I want to draw a circle. And now let's hope. Okay, let's imagine that that's centered. Can I move it? No, I can't. Okay. Well, let's just imagine it's centered at this origin. Okay. Then I'm going to draw a line from the origin to the outside. Well, if this is the unit circle, then obviously this is the radius, and it has a radius that is equal to 1. And we call that theta. And this point here, well, that will have coordinates x, y, because anything on our Cartesian plane has coordinates x, y. Well, we can also say it's cos theta, sine theta. Some of these values of sine theta and cos of theta aren't the nicest numbers to deal with. Aren't the nicest numbers to deal with. There's some forms of irrational numbers and just long-winded, not repeating decimals, so we don't really like just remembering off the top of our heads. But some of them, however, some of them have exact numerical values. So we have some of our angles, some of our values of theta, that will have exact values. Now, there's a proof that we can do to do it, or there's a little bit of a table. And in all honesty, I find that the table is going to be the easiest thing in the world to try and figure out. So, make sure we remember this table. So we have sine, we have cos. And then I want to draw a square root. This is going to be 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. And then let's draw a line all the way across. Now from sine, you're going to go 0, 1, 2, 3, 4. Cos, you're going to go the other way around. 4, 3, 2, 1, 0, and then a line and a 2 below. And a 2 below. And I'll also just make a note that tan equals sine over cos. Now you're probably looking at that and thinking, well, how does that table help me? How is that useful at all? Well, we're going to go through it now. Okay, so we're going to go through a couple of examples. So find the sine of 60 degrees. Now this is a common non-calculator question. All right. So this will be something that you're not going to have a calculator for, so you can't just plug it in and find it out. You need to remember the exact value. And if you're ever lost, this table is going to be how you figure it out. So I'm going to go to the 60, okay? So now I'm just going to be working with these two numbers. Now the first row is sine and the second row is cos. So for my first one, it's going to be that number there. So it's going to be the square root of 3, because we have the square root there, square root of 3 divided by 2. And that's your answer. Square root of 3 divided by 2 is your answer. You take the square root of the number at the top and then divide it by 2, and that is how you find all the exact values for those degrees. Handy little trick. Next one. Find tan of 30 degrees. How are we going to find tan of 30 degrees? We don't know how to find tan off exact values, but we do know that tan is equal to sine over cosine. So we're going to have to find the cosine of 30, the sine of 30, and then find the quotient of them. So we're going to start off sine 30 equals. So we're going to go 30 again. 1. So it's going to be the square root of 1 over 2, which is just equal to 1 over 2, because the square root of 1 is just 1. Cosine of 30 is going to be root 3 over 2. Okay. Now tan of 30 will be equal to sine 30 over cosine of 30, which is going to be equal to a half divided by root 3 over 2, which equals 1 over root 3. And now we know that we don't really like surds in our denominator, so we're going to do something to this fraction. We're going to times the top and the bottom both by root 3. So it's going to be 1 times root 3 over root 3 times root 3, which equals root 3 over 3. And if we don't remember this process is called rationalizing the denominator. Which should have been touched on a little bit in 10 Pathway 1. Now, the only thing that's going to trick us up in these types of exact value problems is finding out the angle of reference that we're working with. So, we need to remember that our angles in question are always the angle made with the horizontal. the angle made with the horizontal. So we're always after the angle that our line makes with the horizontal axis. Okay, so it's time to draw another bit of a diagram when we're going to want to try and find the cosine of 210 degrees. Okay, if you can automatically know the exact value of cos of 210 degrees, well, good job, and you don't need to do all of this. But for those of you who don't, which is me, I'm going to draw a diagram. Okay? And now I'm showing it like that. Actually, no, I'll draw the full one. I'll go a little bit down, try and make it even. So this is my plane. And now I know I always start here. That is my line 0 degrees. That's 90 degrees. That's 180 degrees. 270 degrees. And then all the way back to 360. So if I'm going around 210 degrees, it's going to be something like that. And I'll call that 210 degrees. And then I'm going to draw a line. The ruler is just making me show how wrong my diagram is, but that's okay, you know. You're not going to get marked down for that. Well, if that whole thing is 210 degrees, the angle made with the horizontal is made with this line here. So we want to find how big that is. Well, it's going to be 30 degrees. Okay. It's 30 degrees because we have the 180 from our opposite ends of the x-axis, and then the 30 degrees is what's left over from that 210. So it's 30 degrees. Therefore, we want to find the cosine of 30 degrees. And we figured out from the question before, cosine of 30 is root 3 over 2. So it's going to equal root 3 over 2. But we need to be careful, because let's think back to our first lesson on trig. Revision of trig. All stations to Cottesloe. In my third quadrant, cosine is actually negative. Okay. So we also need to take into account the value of the cosine and sine of the angle when we're doing our exact values. We need to remember if cosine is positive or negative in the third quadrant. Since it's negative, we can say that the cosine of 210 degrees is equal to negative root 3 over 2. 210 because that is the entire angle I was actually after at the start. If you write cos of 30 degrees equals negative root 3 over 2, well, that answer would be wrong, because cos of 30 degrees would be something like that. That would be cos of 30, but that's not what we're finding. We're finding the cosine of 210. And that is how you find exact values of different degrees.